In this lesson, we're going to use two-way tables to represent data. The success criteria is I can read a two-way table, I can make a two-way table, and I can use a two-way table to describe relationships between data. A two-way table displays two categories of data collected from the same source. You randomly survey students about their grades on a test and whether they studied for the test. The two-way table shows the results. Each entry in the table is called a joint frequency. So if we can see here, we have 4 different joint frequencies. We have 21 students who passed and studied. I have 2 students who passed and did not study. I have 1 student who failed and studied. And then I have 6 students who failed and did not study. So for example 1, we're going to take a look at the same table we just saw. You randomly survey students about their grades on a test and whether they studied for the test. The two-way table shows the results. How many students in the survey studied for the test and passed? Well, the way I can answer this question is I can just look at this studied column right here. So we know that they studied, okay? And then there's only 2 options given that they studied. They either passed or they failed. And because I want to know whether or not the students that studied for the test and they passed, I just look at the passed and studied, and that is 21. So 21 students passed and studied. Or you could say studied and passed. Anyway, now we're done with this one. The sums of the rows and columns in a two-way table are called marginal frequencies. So, using the same data set, you randomly survey students about their grades on a test and whether they studied for the test. The two-way table shows the results. Find and interpret the marginal frequencies for the survey. So what I'm actually going to do with this table is extend it so I can calculate the totals. So I'm going to make a new column here, and then I'm going to make a new row here, and I'm going to combine them like this. So this is going to be my total, and this is going to be my total. And then I'm going to extend this, and then right here. So now what I'm going to do to find the marginal frequencies is just add the columns and add the rows. So I know that I have 21 students who passed and studied, and then I have 1 student who failed and studied. So to find the total amount of students who studied, I just add these 2 numbers. So 21 plus 1 is 22. And then the total students who did not study is going to be 2 plus 6, which equals 8. And then over here, to figure out the total students who passed, I just take the 21 students who passed and studied, and then the 2 students who did not study but still passed, and add them up. 21 plus 2 is 23. And then I have 1 student who failed and studied, and I have 6 students who failed and did not study. So I have 1 plus 6 is equal to 7. So I know I have 7 total students who failed. And either way, I could either add the row or add the column of the total, and I will get the total people who we surveyed. So 27 plus 3 and 22 plus 8 is both equal to 30. So I know I have 30 total students that were involved in this study. And now we're done with this one. For this example, you randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown in the tally sheets. Make a two-way table that includes the marginal frequencies. So to make a two-way table with this, I'm going to figure out what I have for my data. I have my age range, so 12 to 13, 14 to 15, and 16 to 17, and that's for both. And then I also have whether or not they ride the bus or do not ride the bus. All right, so I have my ages, which are 12 to 13. So I'm going to write that down here. 12 to 13 is one category. And then I have 14 to 15. And then I have 16 to 17. So these are my ages. And then I also have whether or not someone rides the bus or does not ride. So I'll break this up here. So this is a little messy. You might want to use a ruler when you're doing this. But anyway, so these are my other categories here. And these are the students. Okay. So now all I have to do is figure out these tallies and complete my two-way table. So this tally right here, the 4 lines with a cross, that's 5. So I have 5, 10, 15, 20, 24 students in the 12 to 13 age who ride the bus. And then I have 5, 10, 12 students in the 14 to 15 age. And then over here for rides the bus, I have 16 to 17 age, that's 5, 10, and then 4, so that's 14. And then for the students who do not ride the bus, I'll go down to 12 to 13. So 5, 10, 15, 16. And then for 14, 15, I have 5, 10, 13. And then for 16 to 17, 5, 10, 15, 20, 21. So now, notice you can see that I've included these other columns. These are to figure out the totals, the marginal frequencies. So I'm going to add a total column here, and then a total here. So right here. And remember, all you have to do is just add these numbers to figure out the totals. So 24 plus 16 is 40. 12 plus 13 is 25. And then 14 plus 21 is 35. And then over here, I have 16 plus 13 plus 21. Well, 16 plus 13 is 29. 29 plus 21 is going to give me 50. And then up here, I have 24 plus 12. That is going to give me 36. 36 plus 14 is also 50. And then I can either, to figure out the entire total of how many students are involved, I can either, well, I could count all of these, or I could just add up these rows or add up these 2 entries in the column. So 50 plus 50 is 100. And 40 plus 25 is 65, plus 35 is also 100. So now that I've made my two-way table, although it's a little bit messy, it has all the marginal frequencies and the totals, and now we're done with this one. All right, so now we're going to do example 4. For each age group in example 3, what percent of the students ride the bus, do not ride the bus? Determine whether there is a relationship between age and riding the bus to school. So I'm going to bring down my two-way table into this example from the previous one. So to figure out the percentages of which students ride the bus and do not ride the bus for each age group, all I need to do is figure out the fraction of students who ride the bus out of the total students who ride the bus. And then the same thing for the students who do not ride the bus. So for students who ride the bus, I know it's going to be 24 out of the total, which is 40. So 24 over 40. Well, if you simplify this fraction, you can divide out a 4 off the top and bottom. You get 6 out of 10. 6 out of 10 is the same as 60 out of 100. So that's 60%. So this is rides, and this is the 12 to 13 age group. And then I'm going to extend this. Now, to figure out the percentage of students who do not ride the bus, you could either do 100 minus 60%, which is 40%, or we could do 16 out of this 40. So this is does not ride. It's going to be 16 out of 40, which, once again, you divide a 4 off the top and bottom. You get 4 out of 10, which is the same as 40 out of 100, which is 40%. Percent quite literally means out of 100. All right, so that's for the 12 to 13 age group. Now I'm going to do the 14 to 15. So same thing. For students who ride the bus, I'm going to do 12 out of my total, which is 25. Since my denominator is 25, if I do 25 times 4, I get to 100. Once again, percent means out of 100. So if I multiply 12 by 4, I get 48. So this is going to be 48% of students will ride the bus from ages 14 to 15, which means if I just do 100% minus that, I get 52%. But let's figure out the fraction that makes that work. If I do 13 out of 25, that is equal to 52%. Once again, if I multiply 4 on the top and bottom, 13 times 4 is 52. So 52% of students ages 14 to 15 do not ride the bus. And then I'm going to extend my table once more. So this is going to be 16 to 17. and I have 14 out of 35. So 14 out of 35. I can divide out a 7 from the top and bottom, and I would get 2 out of 5, which is 40%. And then over here, I have 21 out of 35. 21 out of 35. If I divide off a 7, I get 3 out of 5, and that is 60%. So now that I've completed calculating the percentages given each age group, now if I scroll back up here, I want to figure out whether or not there is a relationship between the age and riding the bus to school. And notice, if I look at the riding the bus, the younger kids, ages 12 and 13, 60% of them ride the bus. Then 14 to 15, only 48%. And then 16 to 17, only 40% ride the bus. Whereas do not ride the bus, since these are just 100 minus this, these numbers, instead of going down, are going to go up. So to answer the question, is there a relationship between age and riding the bus to school? We can see as age increases, students are less likely to ride the bus to school. So we have calculated the percentages of the marginal frequencies given the age groups, and then we analyzed the data, and we saw that as age increases, students are less likely to ride the bus to school. And now we're done with this one.